All right, let's do it again. Velocity versus acceleration. Let's accelerate this debate. Okay, so in this video, I'm going to talk about why specifically how they derived meters per second squared and why we use that, or yeah, why they use it. Also, if you have 10 meters per second squared, you don't have to square the 10. I'm going to try to explain why we don't have to do that. So let's start with velocity. We'll always start easy. Velocity equals meters per second. So we have quantities and units. Let's take red color for quantity and green color for units. Velocity is a quantity, meters per second are units. Again, you could say meter is the unit of distance. Distance is a quantity, and seconds is the unit of time. Time is the quantity. So we have distance over time. Velocity equals distance over time. You travel a certain amount of distance in a certain amount of time. In this case, we always use per 1 second. So meters, amount of meters per 1 second. You travel 10 meters, for example, each second. In the second you travel again 10 meters. In the third second you travel again 10 meters. It's constant. So this is your velocity. This implies v equals meters per second implies a constant velocity. No change in velocity, only a change in your distance in time. So this is no problem, easy to understand. Let's go to the acceleration. Okay. So acceleration, instead of distance and time, we have velocity that is changing in time. Okay. The velocity is changing in time. Do you agree with that? That your velocity is changing all the time. Okay. So you can say that after 1 second, you have 1 velocity. After 2 seconds, you have 2 velocity. After 3 seconds, you have 3 velocity. Is that okay? So your velocity is changing every second. Now, if we consider the units, if we take into account the units at the same time, the unit of velocity is meters per second. So if I'm saying velocity over time, I'm just using the quantities. But if you're going to use the units, then we have units of velocity, meters per second. Units of time is seconds. So velocity over time is the same as saying meters per second over seconds. Meters, you're going meters per second in time. So acceleration is meters per second every second. Your velocity is changing every second. Your meters per second, which is unit of velocity, is changing every second. All right, so how do they come up with meters per second squared? Well, in mathematics, they always like to notate things in the shortest way possible. They always like to make it abstract. For example, yeah, E equals mc squared is the shortest way of notating something very complicated and big. So we can write this in a shorter way. Mathematics, they love to do this in mathematics. So we have a fracture, meters per second. And that, and then per over seconds. And you could write it down as seconds over 1, another fracture. So we have a fracture divided by a fracture. And the mathematical principle is that we take the reciprocal and multiply them. So then we have meters per second times hold on, times, instead of, you swap these around, instead of s over 1, it becomes 1 over s times 1 over second right? So then you have to do m times 1 over s times s, which equals just m over s times s, seconds times seconds, or s squared. And so we have meters per second squared. And that's just another way of notating meters per second over seconds, or velocity over time. That's all that implies. Meters per second squared implies velocity, change in velocity over time, or in time. You can also use numbers in these. Let's say we have 1/2. Let's say we take m for 1 and 2 for s. We have 1/2. So m is 1 and s is 2. So n over 2 over s, which is 2. And you can notate the 2 as a fracture, as 2 over 1. And then, so we basically have 1/2 divided by 1/2 divided by 2, which is a quarter, 1/4. So that will equal so a fracture divided by a fracture, take the reciprocal, becomes 1 over 2 times 1 over 2. That equals 1/4. Now, of course, we can, now we're using numbers, we can directly use the number 4, but over here we are using units. S seconds, s times s doesn't give you a number, so we have to write s squared. So over here we can also, instead of writing 4, we can use 2 squared. Yeah. Okay. So that's 1 over 2 squared is a shorter way of notating 1 over 2 divided by 2 over 1. It's just a shortcut. And yeah, so if you have, for example, 10 meters per second squared, that doesn't mean that you have to square the 10. That doesn't mean that the next second you're going 100 meters, and the next second, 1,000 meters, and the next second, you're going 10,000 meters per second. And that's not how it works. Otherwise, it would say this, meters per second squared. If it is written like this, then that would mean that you will have to square this entire thing. Then indeed you would have to square your velocity. So if you're going 10 velocity, then you would have to square it. But over here, as in a normal notation, it's only seconds squared. Only the seconds are squared. That means, that implies just your change in velocity over time. So you have your 10 meters per, so this just implies 10 meters per second over time, or 10 velocities over time, change in velocity over time, nothing more. It doesn't mean you have to square the 10. Otherwise, it would have been written like this. So yeah, those were the 2 points I wanted to talk about today. So yeah, probably won't change anything to the debate, but all right. It's gonna be it. See you in the next video. Where stop? Oh, there it is. No, stop recording. Okay.